Introduction to logical reasoning. Logical reasoning plays a crucial role in development of correct, reliable, efficient software systems. It enables programmers and engineers to think critically, detect inconsistencies, and validate the correctness of their solution. Logical reasoning is a backbone of decision-making processes in artificial intelligence. The formulation of queries in databases and the creation of robust softwares and architectures. In this context, we will dwell into the four fundamental logic properties that forms a foundation of the computational logic and system design. Understanding these properties not only improves program reliability but also enhances one's problem solving and analytical skills, which are essential in the fields of AI, database, software engineering. These properties include consistencies, soundness, completeness, and decidability. Tautology in logic. A tautology is a logical statement that always true, regardless of the truth of its individual variables. It remains valid under all possible interpretations and serves as a foundation concept in formal language and reason. Example: P or not P is this expression is always true because either proposition P is true or negation P is true. Symbolic representation. T pronounced as top denotes universal true statements. Significance used in validating logical arguments essential for constructing formal proofs. Ensures logical soundness in AI, database, and software systems. Tautology. Example and applications. Truth table of P, not P. The expression P and not P evaluates to true regardless of the truth value of P. This confirms P not or not P is a tautology. Truth table as given. You can refer. You guys please refer. Applications. Logical circuit design, formal verification, rule-based system in artificial intelligence. Real life examples of tautology. It will snow tomorrow or it will not snow tomorrow. This is an ontology because it includes all possibilities. Either it will not snow or one of them will be true. I will pass the test or I won't pass the test. No matter what the outcome, this statement is always true because it covers both the possibilities. If I am hungry, then I am hungry. This statement is always true because this simply repeats the same conditions. It, it's logically certain. Either the light is on or the light is not on. The light can be on or off. The statement includes both, making it necessarily true. If it is raining, then it is raining. The implication is always true because the condition and the result are not same.
Good morning everyone. My name is Sura Reddy. Now I will discuss about what is contradiction. A contradiction is a situation where two or more statements or ideas are in direct opposition, meaning they cannot all be true at the same time. In logic and reasoning, a contradiction happens when one statement directly negates another one. Example: Statement A: It is raining outside. Statement B: It is not raining outside. If both are claimed to be true at the same time and place, they contradict each other. In simple terms, a contradiction is when something does not make logical sense because parts of it cancel each other. A contradiction is always false. Example: P and not P. This indicates the symbol of false. Now we will see the examples and the applications of contradiction. It appears in faulty logic or invalid condition. It used to detect the inconsistencies or bugs in the system. The common example is everyday language. I always lie. If this is true, then it must be false. A self-contradiction known as Lear paradox. In logic or math, statement A: All birds can fly. Statement B: Penguins are the birds that cannot fly. These two contradict each other unless the generation in A is qualified. Literature. Shakespeare often used contradiction for dramatic effect. Oh, braving love, oh, loving hate. It leads to Romeo and Juliet. These are the oxymorons, a literary form of contradiction. Applications of contradiction, mathematics and proofs. Proofs by contradiction are assuming something is true. Show that this leads to a contradiction. Conclude that the original assumption must be false. In computer science, in logic programming and automated reasoning, contradiction helps to determine invalid inputs or faulty rules in systems like Prolog. In philosophy, it is used to challenge arguments by exposing internal contradictions, a method often found in Socratic dialogues. In law and debate, lawyers or debaters can expose the contradiction in testimonies or arguments to undermine credibility. Real life examples of contradiction. I will never tell the truth. If the statement is true, then it's false. And if it is false, then it might be true. This self defeating loop is what makes it a contradiction. It's famously known as the Lear paradox. Most real life contradiction examples are I am vegetarian, but I eat chicken sometimes. Contradiction between claimed identity and an action. This product is guaranteed to work, except when it doesn't. Contradicts the idea of a guarantee. He is both married and a bachelor. Logically impossible being both at once. I am absolutely sure that nothing is certain. This certainty contradicts the content.
So, today let's talk about entailment. Let's begin by understanding the core concept of entailment in logic. Entailment is a logical relationship between two statements, where one statement logically follows from the another. We say that statement A entails statement B if whenever A is true, B must also be true. This is symbolized as A entails B. For example, if A is P and Q, that is P conjunction Q, then B could be just P. If both P and Q are true, then P must definitely be true. So A entails B. It is the foundational idea in logic and reasoning, helping us understand which statements logically follow from others. Now, let's explore how entailment works practically using truth tables and some real world applications. In a truth table, when A entails B, it means there is no scenario where A is true and B is false. So, if A is true, B must be true. That's the definition of entailment. This concept isn't just theoretical, it's very useful in areas like logic circuit design, formal verification, and especially in AI and rule based systems. For logic circuit design, where we want certain outcomes to be logically following from inputs. For formal verification, it ensures that systems behave as intended. And for AI and rule based systems, rules depend on logical consistency and entailment to draw correct conclusions. So, entailment is really important in both theory and practice. Finally, let's look at some example statements to bring it all together. Let's look at the first statement. If it is a cat, then it is an animal. This works because all cats are animals, so if the first part is true, the second must be true. Coming to the second example, if it is a square, then it has four sides. Again, that's true by definition, so the conclusion is entailed. For the third example, if I am driving a car, then I, I am in a vehicle. A car is a vehicle, so if the first is true, the second follows logically. For the fourth example, If today is a Monday, then today is a weekday. Monday is always a weekday. If it is Monday, then the statement about being a weekday is automatically true. Each of these is a clear example where the truth of one statement guarantees the truth of another. That's entailment in action. And thank you.
So, the next topic is satisfiability of a logical formula. So, let's start with the definition. A logical formula is satisfiable if there is at least one assignment of truth values to its variable that makes the formula true. So, this is a formula and it needs to contain at least one value or assignment such that the whole statement becomes true. So, in this specific statement, let's see, if P is true, the whole statement becomes true, and if Q is true, the whole statement becomes true, and if P and Q both of them are true, the statement again becomes true. So, there is a chance that this statement is true. Assignment value of truth is there in the statement or formula. So that makes this formula satisfiable. We can see an example of a formula being unsatisfiable, which is this one. So in this you can see the left of the AND operation is P and to the right it's not of P. So no matter what we do, let's see, this is true, that means this becomes false. So in an AND operation, if one is true and the other one is false, the value is always false because both of the statements must be true in an AND statement. Only then will the statement be fully true. So this is never a satisfiable formula. That makes it unsatisfiable. Or you could say, that there is no truth assignment to it. So let's see some examples. This is the last example we saw, and for this one, a value has to be true or false, or when b value is true and c values can be false. There are like 6 possible solution for this single thing. Like multiple truth assignments can satisfy this formula. See, if this is false and this is false, this can be true, and if these two are false, this can be true, and if these two are false, this can be true, and there are multiple ways that this statement can be true. So this is satisfiable. And see, it's like last time we saw AND operation. So x can be true, y can be true, z can be false. This is the only way this statement becomes true. X has to have a value of 1, which is true. Y also need a value of 1, and z on the other hand needs a value of 0 because right here we can see it's not of z be true. Only then the statement becomes satisfiable. So if z is false, that means not of z is true, which makes the whole statement satisfiable. Let's see again. X is true, y is true, and z is false. Let's see some of the applications of this. So SAT solvers. What are SAT solvers? SAT solvers are widely used for solving logical constraint in hardware verification, puzzle solving, etc. And artificial intelligence. Let's talk more about artificial intelligence rather than going for SAT solvers. In artificial intelligence, there are, what do you say, a lot of reasoning and logical solutions of formulas, problems. All these formulas are done or solved using the satisfiability. If a condition is satisfied, then do this kind of like condition based satisfiability. We check that in artificial intelligence and see come up with a suitable solution. That is why satisfiability is used in artificial intelligence. And In formal verification, that is actually a part of SAT solvers, or SAT solvers can be called as a part of uh, formal verification. But instead of just checking the values or testing it with examples, in formal verification we check the correctness of the value. That's all in satisfiability. Good day.